Most of you treat the inequality differently from the normal equations. Obviously, this is a quadratic inequality because the highest exponent of the variable is 2. You still follow the same steps, okay? Now, when you solve for an inequality, especially when dealing with equations, step number 1, you first have to simplify. If they're brackets, the fractions, get rid of. Step number 2, write the equation in standard form. Step number 3, factorize. And step number 4, take each factor and equate it to 0. And then solve for x, which is the last step, step number 6. Now, here you need to ask yourself, which step do I still need to follow? You don't need to simplify here because everything has been simplified for you. Already the equation is in standard form. The standard form, guys, doesn't change. It is still ax squared plus bx plus c is equal to 0. It's just that here, instead of using the equal sign, they have the inequality. Already here, you can tell that this equation has been written in simplified or standard form. So there's no point in writing it in standard form. So you just have to follow the next step. After writing this in standard form, you just need to factorize. Let's find factors here. You will notice that whenever you factorize, you have to follow steps as well. The first step of factorization is always checking if you've got a common factor. That is the first step. When you determine the common factor, especially dealing with variables, you will always take the variable that is in all the terms out. So the variable must be in all the terms. Here we've got only 2 terms. We've got the first term, which is x squared, and the second term, which is 2x, all right? And in those terms, you will notice that the variable x is in both of them. So we're going to take it out as a common factor. And then figure out that if you take out x as a common factor, what must the exponent of that common variable be? The exponent of the common variable must be the lowest exponent of that variable. And here the lowest exponent is this one over here. So basically this x that I'm taking out as a common factor will be to the exponent of 1. Even though we don't write it. And all you have to do, guys, is to ask yourself one simple question. What must I multiply with x for me to get x squared? I will multiply it with x to the exponent of 1. So that when I add, so when I say x multiplied by x to the exponent of 1, I will write it as a single base of x, but I will simply take these exponents here. We have 1 there, we have 1 there. When you add them, they will give you 2, and it will take you back to the original term. Then I have plus in between. I've got 2, which will not be affected in this case. And then when it comes to the other x, you're going to ask yourself, what must I multiply it with x again for me to get that x to the exponent of 1, which is x? The answer is you just multiply it by 1. So 1 will be multiplied by 2, but because it's a factor of 1, we normally do not write a factor of 1. So I'll just leave it out, and you close the bracket. Keep the inequality which is less or equal to 0. For the next step, ignore the inequality. We are going to work out what we call critical values, which takes you back to what we did. So now what we have is that we've got A multiplied by B is equal to 0. A is x, B is x plus 2. You take this and you equate it to 0. Then you will say A, which is x, is equals to 0, or B, which is x plus 2, is also equal to 0. And then you solve for x. In the first one, we don't need to solve for x because x has been solved. So you'll end up having x is equals to negative 2 in the second one. These two values, we call them the critical values, which is CVs. So what do we have as CVs? We've got x is equals to 0 or x is equals to negative 2. You're going to take your critical values and write them in a number line. So this is what we have as a number line. In your number line, you will start with a critical value that is smallest. So between 0 and negative 2, which one is the smallest critical value? Negative 2 is. So 0 is bigger than negative 2. Because the inequality has an equal, because this line at the bottom here means equal, your critical values will be shaded. So I'm going to put a shaded dot over there. If there was no equal sign, then your critical values were going to be open. If there was no equal sign. But here I don't have to write them as open. It means that when you determine your solution, the critical value will be included, grade 9 again. Then you're going to choose any number that is less than negative 2. I'll choose negative 3. And then choose any number that is between negative 2 and 0. I'll choose this. I always choose the easiest, negative 1. Then a value that is greater than 0, I'll just choose 1. What you are going to do now is to go to the equation that was written in standard form, which is the equation that was already given. You go into that equation and you test. So wherever there's x in that equation, you will start by testing with negative 3. So wherever there's x, you will substitute negative 3. Remember when you do your substitution to always put your substitutions in brackets. So all I'm going to do is substitute negative 3 into that equation wherever there is x. What do we get? So we've got brackets, -3, close brackets, raise it to the exponent of 2, then plus 2, brackets, -3, then close brackets. It gives me 3. What this simply means there is that for any value that is less than -2, for any value that is less than -2, your answer will always be positive. We don't care about the value that you found. We care about the sign of that value, which is positive. Do the same thing. For values between 2, -2 and 0, what do we get? You go back to this, and a value that is between -2 and 0, I chose -1. So wherever there's x, you will substitute -1. It gives me it gives me -1. So when I substitute -1 into the equation, I get -1. We don't care about the value, we care about the sign of that value, which is negative. Now, for values that are greater than 0, I chose 1. It gives me +3. So for values that are greater than 0, I'll always get positive. But please note that the inequality wanted us to find the values that are less than 0, less or equal to 0. And in this number line, less is between -2 and 0. It follows that for you to get values that are negative or equal to 0, the value of x must be less or equal to 0, or it must be greater or equal to -2. Another method that most of you get taught, which normally works, they'll tell you to look at the value of a. If it's positive, then you draw a graph, a parabola graph, which passes through your critical points. It'll pass through 2 and 0. Where the graph is below the line, values of x there, which is between this, is negative. Where the graph is above the line, then the values of x there will be positive. Where the graph is just above the line, then the values of x are positive. So you will still get the same solution. Probably you saw the number line for the first time. Try it out, okay? Try it out. If it doesn't work, it's fine. You can use this over here. But this equation here, this method of drawing the parabola becomes a problem when you are given fractions. So the testing becomes easier when you're given fractions. You don't have to change your method. You still continue with the method that you already know. But the ball is in your court. You decide, choose what works for you. Okay, let's get to this one here. Here they want us to determine the values of k for which the roots of x into 1 over 2x plus 2 close bracket is equals to k squared I equal. Now here you need to note that we are dealing with the nature of roots, which is delta. So the first thing that you need to think about is delta. And the formula for calculating delta is b squared minus 4ac. But you need to know the rules of delta. If delta is equal to 0, then the roots will be equal, rational, and obviously real. So your solution will be equal, rational, or real. I have made a video on the nature of roots. Just go to the channel and search nature of roots, where I've explained everything thoroughly. If delta is less than 0, then we say that the roots are not real. They're just imaginary, okay? Complex numbers, they're just imaginary. However, if delta is greater than 0, what we know is that the roots will be real. So whenever delta is greater than 0, the roots will be real. So this is condition 1, this will be condition 2, this will be condition 3. But condition 3 will have 3.1. If delta is equal to 0, right? And it is a perfect square. PS stands for perfect square. Then the roots will be unequal. As well as rational. However, if the roots are not, which is 3.2 now, if the roots are not perfect square, or basically if delta, the value of delta is not a perfect square, then your roots will still be unequal, but they will be irrational. So basically, delta being a perfect square or not only determines if your roots are rational. If it's a perfect square, your roots will be rational. If it is not a perfect square, your roots will be irrational. But I'm going to go back to the question, what the question is asking us. Basically, the question wants us to determine where the roots are real. And beside being real, those roots must be equal. So basically, we just need to use condition number 1. We don't need to use the other conditions. But first we have to find delta. And for you to be able to use this formula, for you to be able to determine what B is, you need to make sure again, guys, because this is normal. Delta is normally applied for quadratic equations. you need to make sure that your equation is in standard form. First, make sure your equation is in standard form. Let's do that, because it's not. That is not in standard form. We can't determine what B is. We can't determine what C is. That is not standard form. So what are we going to do? Simplify. Multiply this out, break the bracket first. So it will give us x times x. So I will still have a coefficient of a half. X times x will give you x squared, because when you multiply x times x, variables, when you multiply them, you just add the exponent. So 1 plus 1 is 2. And then a constant, when you multiply it by variable, you just attach the variable to the constant or the value. And on the right-hand side, you will have negative k squared. Now, the only thing that's left is to make sure that this is equals to 0. So to make sure that it's equals to 0, all I am going to do is to transpose k and take it to the left-hand side. To transpose k here, I will still have 1 over 2 x squared plus 2x plus k squared is equal to 0. Now you will notice that according to this, a is a half, b is 2, c is positive k squared. I'm going to use this equation over here to find my delta. I will have delta is equals to, where there is b, I need to substitute 2. And this will be squared. So where there is b, I actually substituted 2. And then I'll have minus 4, where there is a, I will have to substitute a half. So where there is a, I substituted a half. And where there's c, I will substitute positive k, which is squared. Again, where there is c, I substituted k squared. Simplify this. You will end up having 4. 2 squared is 4, minus a half times 4 will give you 2. It'll be 2k squared, and that's it. However, they said that we need to find the values of k where the roots are equal. The roots will only be equal when delta is equal to 0, which is this condition over here. So all I did was just to make sure that where there is delta, I substituted 0. So where there's delta, I'll just substitute 0 over there. Where there's delta, I'll just substitute 0 into the equation. Then solve. You will take 4 to the other side. It will be negative 4 is equals to negative 2k squared. Then divide both sides by negative 2. negative 4 divided by negative 2 will just give you 2 is equals to k squared. To solve k, you will simply find the square root. When you square root, please note that the value that you have will be plus or minus, meaning that k must be plus or minus the square root of 2. And that's what they just wanted. Problem solved. Just like that. Okay. I make sure that I explain everything thoroughly, and I know that it takes a lot of time. This is to make sure that when you come across something like that, you never miss a point and you get it right. Understanding is key. If you're just looking for solutions, there are good YouTubers there that will explain the solution. I just don't explain the solution. I basically am teaching you on how to deal with each of these solutions in case you get something different. Okay, we good? Great. Now we're going to be dealing with equations and exponents. Guys, when it comes to solving for variables in exponents, you need to, at the end, you just need to have same basis on both sides. That is the key. So you need to do whatever it takes to make sure that at the end, you've got same basis on both sides. Now, the rule here comes from this. Guys, maths is general knowledge. People just try to complicate it. Obviously, I'm from the accounting background, I did accounting, I did BCom. So you need to understand what you're doing. BCom is just part of maths, okay? You just need to understand what you are doing in accounting before you can be able to apply. So I respect rules. Okay, in accounting, we work with a lot of rules, and these rules you need to prove to yourself that they're making sense. Think about it, guys. Okay, if I have 3, okay, let me just give you one simple example. Let me say 2. If I have 2 to the exponent of x, right? And on the right hand side, I've got 2 to the exponent of, let's say, 4. Note that I'm simply asking you which value of x will give me a value that will be the same on both sides. Equal means they must be identical on both sides. Guys, x over here can't just be any other value. If I decide to put 3 over there, it means that if x is equals to 3, it means that I'll have 8 on the left-hand side, and on the right-hand side, 2 to the exponent of 4 is 16. It's not working. What if I decide to put where there is x, right? What if I decide to put 5? What is 2 to the exponent of 5? Is it the same as 2 to the exponent of 4? It will not work, guys. So the principle is that for as long as you've got the bases that are the same, for you to have identical answers on both sides, then the exponents must be the same. That's how it works. Okay, so for me to get the same answer here, it makes sense that whatever x value I choose, whatever value of x I choose then, it can't be any other value except for 4. So whatever value I choose here, it has to be 4. Because if it's not 4, then these two sides will not be the same. Are we together? So that is why when we have the same basis on both sides, we just say that for side left to be the same as side right, it makes sense that the exponents must also be the same. If we have same bases on both sides, it makes sense that the exponents must also be the same for both sides to be equal. The reverse also works out. The reverse also applies, okay? So the reverse will also apply. What is the reverse? The reverse simply says that if I've got 2 to the exponent of 3 here, and I've got x to the exponent of 3, For as long as the exponents are the same, it makes sense that the bases must also be the same. So if the exponents are the same, it makes sense that we just drop the exponents and we just equate the bases. If the bases are the same, it makes and the exponents are unknown, it makes sense that the exponents must also be the same. Same bases, same exponent. Same exponents, same bases. That's how it works. You got it. So you need to apply exponential rules to make sure that you simplify. That's all. That's all you need to do. Now, prime factorize. That's the first thing. Okay. When you come across something like this, you need to prime factorize. So prime factorization, you did this in grade 8. Okay, you can use a calculator. I'll try to use my calculator. Let's hope it'll work. Okay. You can use a calculator. And when you use a calculator for prime factorization, show you shortly how it works. Okay. First of all, I can't simplify this base here. This is the only base that I can't simplify. It's already a prime number, so I can't simplify that prime number. So what I need to do here is just to write that 3 to the exponent of x plus 2y as it is. And then you prime factorize 9, and then you prime factorize 27. Okay. 27, I didn't need to put it in brackets, but the 9 I needed to put it in brackets because 9 already had an exponent. 27, it had an exponent. It's just that it's equals to 1. Let me try, and obviously guys, this is quite easy, but I'm trying to make things simple for you because you need to understand that certain things are just given to you. Certain things are just given to you. You just have to know how to find them. I hope this one will work. So I'm gonna have 9. So you're gonna go to your calculator. If you have a scientific calculator to prime factorize, you put in 9 and equal sign, okay? And then you go to shift and then you go to factorize. So it does factorize it for you. It does prime factorize it for you. As you can see there, bottom left on your screen, on your calculator screen, it's written 3 squared. Okay, it's written 3 squared. Right? That's how you will do it with a simple Casio calculator. I don't know how to do it with Sharp. I haven't used Sharp. So when I prime factorize 9 here, 9 will just be 3 squared. So where there is 9, I'm just going to put in there 3 squared. It's refusing to work. I'll just this. See you in the next video as I finish this up. What's up?